welcome to the video lectures on compiler design. So in our previous video lectures we have seen what is parser, what is top-down parser, and what are the types of top-down parsers. So now we'll go into the bottom-up parsing. So what is this bottom-up parsing we'll see, and what are all these parsers we'll see one by one. So this bottom-up parser which builds the parse trees from leaves and work up to the root. Anyway, in top-down parser it is from top to bottom, which is from starting with the root up to the leaves. So here it is reverse, so which builds the parse tree from leaves and up to the root. So in terms of derivation, we call here it as rightmost derivation in reverse order. I'm repeating here, rightmost derivation but in reverse order. So this part we need to remember carefully. So what is this rightmost derivation in reverse order? So we'll see. So let us suppose if I take this grammar, so S tends to A, uppercase A, uppercase B, and followed by E. What is A, what is B, I have written here. Now I want to derive this string A double B C D E. So how to derive? So what I said here, it is rightmost derivation first. So first I'll go for rightmost derivation. S tends to, anyway we have one option, that's why I'll take that option. A, uppercase A, B, then E. So what is rightmost derivation? So between these two non-terminals, anyway I'll come from the right side. So E is a terminal, I don't want to take. Next B is a non-terminal, I have to take. So what is B? I have to derive first. Why? Because it's a rightmost derivation. If it is a leftmost, I'll derive this one first. Is that right? So now B has to be derived. So B it tends to D. So that means I'll write here A and B should be derived as D, then E. You can see, of course, E and D both are satisfied from the right side. So next, from right side, of course you have only one non-terminal, that is A, has to be derived. So what I need to write? A. So you have two options, A, B, C, or I can write B. So shall I simply write B? No. So I have to take this one. So I'll take that one. So A as it is. What is this A means? I have to substitute A, B, C, this D, E as it is. Now if I take again from right side, so again A is a non-terminal which I have to substitute it as B. So B, then B again, C, D, E. Yes, we got our exact input. Now what is this bottom-up parser? Is it like this rightmost derivation? No, in reverse order. That means first you need to take this string, and in that string what you have done first? This B is reduced as A. Is that right? So this B is reduced as A. That means you have taken that the production, that is A tends to B. Next here what you have done, in place of A, B, C you have written A. That means A tends to A, B, C. Now what you have done here, in place of D you have written B. So that is B tends to D. So like this. So this is what you have done, and finally whatever you got A, B, E, and this you reduced as S. So this is what rightmost derivation in reverse order. This is, we call it as bottom up parsing. In bottom up parsing, first you need to start with the string and you have to get finally a root node. So that is what, or start symbol you call it as. So we'll take another example. Again, let us suppose this is a grammar, and what I want to derive is ID plus ID into ID. So how to derive actually? What happens? Anyway, it will be rightmost derivation in reverse order. First I'll go for rightmost derivation. E tends to, which one I need to take? So let us suppose I'll take E plus E. So here you can see what is E plus E, which has to be taken first. Definitely this right one. So E plus, what is E means? E into E. Now again rightmost, what is that? E. This E has to be written as ID. And now the next one is this ID is over. This E has to be derived. Now like this. Now finally from right side, what is the non-terminal? This one. This is id plus id into id. So this is what rightmost derivation in reverse order. Now we'll see. So this is rightmost. I will go for reverse. That means first which has taken id. id is reduced as e. Next what happened? This id. This is reduced as e. Next what happened? This id. This id reduced as e. Next what happened? E into e reduced as e. Next e plus e reduced as e. So this is what happens. This is, we call it as bottom-up parsing. So like this we can have bottom-up parsing. Remember this point, this is rightmost derivation in reverse order. And some terms we need to remember here, some terminology. If you see, like each time what you are doing, let us suppose if I take in reverse, your id is replaced by e. Is that right? So your id is replaced by e. Here this id is replaced by e, here also, and here e into e replaced by e. So this is, we call it as handle. That means here id is called as handle. That means whichever you want to reduce. Of course here also id, here also id. Here what you want to reduce? E into e. So e into e you call it as handle. So why? Because this handle you are taking and this handle you are reducing. So that means handle means which is the right hand side production of the part, we want to reduce it with the left hand side. So that is what reduction. Even in this example also you can see. So here a b c, you can take here a b c, which is your handle, and you have to reduce it by a. Is that right? So here d is the handle and you have to reduce it by b. So this is, we call it as handle. And what is, so this is, we call it as handle. And now what is, when you substitute, when you reduce like this, this is, we call it as handle pruning. Pruning means simply reduction. So this is what handle, what is handle and what is handle pruning, simple terms. So wherever you want, when you want to reduce a right hand side production with the left hand side, that you call it as handle pruning, and whatever the right hand side production, that you call it as handle. Now we'll see one of the bottom-up parsing technique, that is SRP, which is shift reducing parser first. So we'll see this one, shift reducing parser. So what is this shift reducing parser? So here we'll have 4 actions to be performed. One is to shift, other one reduce, and other accept. The last one is error. So shift in the sense, whenever you want to take an input symbol, and what is the symbol, and it will be shifted onto the top of the stack. So I'll explain it with an example. So first take these terms, and reduce means whenever there is a chance of reducing, you have to reduce it with a handle within the stack with a non-terminal. Accept means finally if you reach to the root, or you call it as start symbol of the grammar, then you can say that accept. If you don't get, then you can say it is some error or syntax error. So that is what another action. Now there are 2 conflicts. So here 2 conflicts you will find, shift reduce is conflict and reduce conflict. So we'll say all this with example. Again I'll take the same grammar which I've taken the example previously. So e tends to e plus e into e, open brace e slash e minus e, and id I have taken. So again I want to derive, that means I want to get this one. I want to take a string id plus id into id. So I want to reduce it, and I have to find whether this input string is accepted by the grammar by using bottom-up parser. Of course in top-down parser, how we need to do, we have seen, we have to take from the start symbol and we have to derive it to the string. Of course it goes till the leaves, but here in reverse, no, it starts from the leaves. That means from input string you have to finally get the root node. So that's what we will do here. And anyway, initially I'll take empty stack. Of course we'll make it a $, and I'll take input here id plus id into id, ended with the $. So we have 4 actions only. One is shift, other is reduce, other is accept, other is error. So any one of these actions to be performed. So what is the first action? Anyway, stack is empty. Of course, dollar represents empty stack. So now we have to shift first. So I'll shift it. So what happens here? I'll shift ID. So shift ID. So if I shift ID here, so ID will be written here. Now what you need to do, and this ID is shifted, and now what is the next thing? So ID is there here, plus is there. What you need to do? I may reduce ID. So how to reduce? ID is reduced by E. So that's why dollar ID is reduced by E. I'll write, and here plus ID into ID as it is. So I'll write here reduce ID. So that is, I'll write like this, reduce E tends to ID. That means ID is replaced by E. Next, what I need to do? There is no further reduction is required. There is no further reduction is available. So plus to be shifted here. So I reshifted plus ID into ID. Dollar I have written. Now you can see, after shifting, I'll write here shift. Now E plus, can I reduce? No. So E plus ID is there, I need to shift. So ID shifted, I have to write ID dollar here. Now what I have done, shifted ID. Now can I reduce ID? Yes, I can reduce ID. So that's why E plus ID will be reduced as E. So here star ID as it is. So what you have done, reduce E tends to ID. Now you can see here, what next you need to do? Here you have E plus E. So E plus E, can I reduce? Yes, I can reduce it as E. I can write it, but I may have a chance, I may have an option to shift, which has to be done here. So there are two options now which has to be done. Either I can reduce it or I can shift this star here. So which has to be done? So how to take this decision? So this is what we call it as shift reduce conflict. That means I may reduce E plus E as E here. I may shift star. In both options I can get the answer, but which has to be done? This is a conflict. Okay, so let us suppose I'll go for this one, shifting here E plus E star. I'll do both actually. So ID I'll write here. So what I have done, shifted star here. Okay, in other option here I'll write dollar. Let us suppose reduce it, E plus E should be reduced as E, and here you will find star ID dollar, and what you have done, reduce E tends to E plus E. So next what you need to do here, E plus E. Anyway, first I'll complete this one, star. What is the next thing we have? ID. So ID shifted, so dollar here. So shift ID, I have shifted. Now what you need to do, E plus E star. Can I reduce E star ID? No, only ID can be reduced as E. So dollar here and reduce ID. Now you can see E star E, can I reduce? Yes. So E star E can be reduced as E. So that I'll write here, reduce E star E. Now here you can see what is E plus E. Can I reduce? Yes, as E. So you can see now reduce E plus E. So now you can see, are you getting the root node? Yes. Start symbol? Yes. So like this you can perform, and finally you got root node, and you can say that yes, accept. So like this you can write. Now if I go in this manner, here what you have taken E plus C, the star is shifted here, star, let us suppose E plus C is shifted, it will be like this, and next dollar, here E star should be taken, here ID will be remaining. Now shift star, that is shifted. Now you can observe what next, E star ID should be shifted. Now I'm writing shift ID. Now you can see E star ID, E star. What is ID? Can I shift it as, can I reduce it as E? Yes. So from this one ID should be reduced as E. E tends to ID. Now what is E star E? Can I reduce? Yes, E star E as E. You can reduce, and finally, yes, I reduced, and finally E star E reduced, and finally I got this one. Finally I can say accept. That's right. So like this we can get the answer. But if you clearly observe which answer is correct among between these two, even if you revise our what is the definition of bottom-up parsing, it is a rightmost derivation in reverse order. What is rightmost derivation in reverse order? If I go with our example, which has to be reduced first, either E star E or E plus E. You can observe here, first I reduced all IDs, then E star E is to be reduced, then E plus E is reduced. Is that right? You can see after this ID is reduced, E star E is reduced as E, then E plus E reduced as E. This is correct only, no? Anyway, in the operative precedence also, if you consider addition and multiplication, which has to be taken first? Multiplication, no? Multiplication should be performed first. So in that case, if you go, I think this is the correct answer. E star E to be reduced first. So whereas this is a wrong, but how can we know in shift reducing parsers? We don't know like this. So there are shift reducing parser which will not allow us to take either to shift or reduce. There is no commands or actions are given when to shift and when to reduce, but it is telling like 4 actions to be performed, like shift, reduce, accept and error. So here this is a one conflict, which is, you call it as shift reducing conflict, where here you are getting. So this is shift reducing conflict, you can see. So I explained about SR parsing, and also I told you about shift reducing conflict, how it will encounter in the shift reducing parser. What about reduce conflict? Let us consider, I will add one more production to this one. E tends to E plus ID. So let us suppose E tends to E plus ID is also there. Assume like this. Now you can see the step here. Yeah, here in this step you can see when I entered into E plus ID, what is the next step we have done? ID is reduced as E. But if I take this one, let us suppose if the situation is like this, when you go for shift reducing parser, in this situation you have two options. One is you can reduce ID, another is you can reduce E plus ID also. E plus ID as E also you can reduce. You have two options which are both are reduce only. So previously we have seen the options, one is shift, one is reduce, but here two options which are to reduce, either to reduce only ID or either to reduce total E plus ID. So again it's a conflict, no? So this sort of the conflict may also occur in shift reducing parser. So this is, we call it as reduce conflict. That means you may have options like two reductions are available, so which one you have to do? So that's what, that is reduce conflict. If you have one shift and one reduce, then it is called as shift reducing conflict. Here it is reduce conflict. So two conflicts we have. So this is about shift reducing parser, and about, of course, conflicts or disadvantages in shift reducing parser. So how to avoid these things means we have to go to the next parsing techniques. Those are LR parsers as well as operator presence, where you don't find these sort of the confusions or conflicts, whether to shift or reduce. You have a clear actions will be given here, whether to shift or reduce. So we'll see all those things. How you have to do that one in LR parsers, and especially in SLR and NCLR, and of course LALR, and how to do that one in operator precedence. We will see that one in the next video lecture. Thank you.